Okay, what is up, team? We're going to be doing another Leetcode today. This is your boy, the Canologist. So, Excel sheet, column title. Given an integer, column number, return its corresponding title as it appears in an Excel sheet. Okay. So right here, this is one of those questions where you need to know the ASCII values for capital letters. So when I say ASCII, I want to be explicitly clear as to what I am referring to. ASCII. Right? So this is a standard for how you classify these elements that you're using both on the screen as characters. It's like A, B, C, D. Like each has an individual character. So what we're going to do is look up ASCII characters for capital letters only. ASCII value of uppercase alphabets are from 0 to 90. So let's go to Geeks for Geeks. Let's check. Okay, so I hate these stupid signups. Like everything tries to extract an email from you. It's so spammy nowadays. Like this is why I create all this content for free, because I don't want to water down value and just like, hey, I'm trying to take, right? It's like, no, let's just do something useful and just put it out there. You know, like I'm not always trying to ask for an email. These mini protein shakes are so convenient though. For me, I need to get a quick 30 grams of protein in, and it has to taste good. Like I'll use one of these shakes. Program to display all the alphabets below. Okay, so let's see how they're printing characters. So that's character C in range. So what they do is they classify a character C, and so the ASCII is a value. So ASCII is a standard, and the ASCII values are used in tandem with this character portion right here. So if I was to go character 97, you get A capital, right? If you get A, B, C, D, so 97, 98, 99, 100, all the way until, or from 65 to 90. So lowercase values are from 97 to 122. So we just go from 65 to 90. So this is that makes sense, because all you do is add 25 letters to 65, you get 90, right? So you go 65, 66, 67, 68, 69. So they go all the way from range 97 to 123. And if you're doing lowercase, the reason they go to 123 is because the for loop for Python is non-inclusive, which means I'm actually going from 97 to 122. So I have to put it as 123 because it'll go to n-1 iterations. All right, so I just want to be clear with that. That's why they go to 123 here and not 122, even though the ASCII values go up to 122. Okay. So back to the question. Okay, so we found the ASCII values. So I'm just going to note it here on my whiteboard. I hate these stupid like pop-ups. Just let me upper. I'm not going to save anything. Upper. So my values for upper are 65 to 90. 65 to 90. This means when I loop, I'm going to want to go to 91, as we talked about already. So let's go back to the question again. It's given the integer, returns corresponding column as it appears in an Excel sheet. So now what I have to do is I have to map 1 to 26. So 1 to element 65. So right here, 65 is the element for A, But according to the Excel sheet, A is supposed to be column 1. So to give me column numbers, I have to add a letter. So what I'm going to do right here is I'm going to predefine a dictionary. I'm going to predefine a dictionary with the values. That's what I'm thinking. I should predefine a dictionary with the values of all the ASCII elements. So for example, I like to call dictionary stores, just so if I say dict, if I put dict dict, it might overlap with something that's in the program already as a built-in. So I just use a completely different variable name to store my dictionary. So what I'm gonna do is here, I'm gonna go A, I forgot how to do this in Python. Dict in Python. Do I just go equals or colon? What do I do? Yeah, so just strings. Okay, so A is character 65. You see? So I also need to create a standard for how to add elements. Because if we go down to the constraints, we can have up to 2 to the 31 letters. So it could be A, B, A, B, C, or A, B, A, C, A, D, A, D. And then it keeps going all the way until it hits column B, right? And then you have to use something to classify column B, right? So I want to do this the right way. I just don't know. I have to map A to 1 up till 26. Like 27, 28, 29, 30. That's the thing. I want to see test cases. I have to model this after test case. So if I go test case, column number 1, column number 2 is 28. If I run it, let's just run it. Let's see what's going on. Okay, so A, 28 is AB, and then this should be 701 ZY. So you see here, what's happening with these columns is it increments. So I have to figure out at what point does it increment. So after you go through all the combinations of A to Z, so that's one letter. So let's say I go A is going to be 1. B is going to be 2. C is going to be 3. Let's call it return the column title as it appears in the Excel sheet. So the only thing is, once you get to the new columns, how do you add one? So I imagine if you're at row 700 right now, because this goes up to 31 columns. So we're at row 700 right now, it's going to be Z, right? And after you go to like 1,000 rows, it's going to be 3 letters now. So combinations up to 3 letters. So this is the scary part. I'm not trying to figure out how to deal with it. How about I'm just gonna try this. 27 would be AA. $27 would be AA. 27 is AA. How do I get to? I have to figure out how to add. So first we also got to create a column title. We'll just keep eliminating things that we know how to do. So column title is going to be an empty row. A is going to be 1. I'm not gonna lie, I'm lost. I'm completely lost with how to solve this. I think the question is incomplete because it doesn't really give full explanation behind the pattern. This should be a medium, finally an easy. Oh. Acceptance rate 36%, okay. Extend letter A to have value of 1, B. That's what I'm thinking, go to 26. Let's just wing it because like these discussions aren't really helping. Let's see what I know how to do. Okay, what I know how to do is at least one row. Okay, we'll worry about the other shit after. So C equals 3. C, D. So most of this question is just going to be me writing out the entire, so A, B, C, D, E. Well, this is good. If we come across these in the easies, we'll know how to do the hard ones later. Like imagine seeing a hard problem that's like asking you to do like BFS with this shit. Like if we can do it in an easy fashion, we can apply the jewels of knowledge to the hard stuff. So E, F, G, H. Wait, I'm trying to work fast. I want to train myself to solve these faster and type faster. Just in case I do a timed question. G. Let's put the caps lock on. So K, 11, L, 12, is going to be 13 LMN 14. Okay. O 15 P 16. Instead of typing it too, I could have just gone actually no, I'm not going to type this manually. This is dumb. Let's give you guys a shortcut. I want to give you guys some value here. So let's take stores and let's fill it up with elements automatically. So for I in range, and it's inclusive, so let's go back to our whiteboard. 65 to 90, 65 to 90 to 91. Stores. Character at I. And then let's put a counter at 1. Position. Position. Equals 1. So source character at I, so this turns it to A, and then I could just automate my filling up this dictionary. So stores I, I'm just creating it, the element, so it's going to be A corresponds to 1. So it's going to be to position. And after position is done, so now it becomes 2, 3, 4, 5, 6, 7. So now I'm thinking, so position is +1. So at the very least, we have a function where we can take a column title. So right now this is empty because we're not going to do anything, but we have to fill it with these characters. Then we have a stores, which is a dictionary, so we can reference variables. So what I'm doing here is I created a position element, so A is 1. And then I'm going from characters 65 to 91. So if I go 65, that's capital A, position 1, and then it goes I increments on its own. So the next loop will be 66, which is B, and then position increases by 1, so that's 2, and then C, 3, D4, all the way up to Z for 26. So it stops there and it fills up stores. So now we know that we have at least the original alphabet. Now we have to figure out how to add multiple elements. So now, all this stuff here was just to fill up stores. So that's what I'm going to put. Actually, no, I'll just space that. So now the next step for me is I have to figure out how to gauge how many rows, how many multiples of columns I have. So if it's just A to Z, if it's AA, like 2, or if I have to use 3, like what's the deciding factor for how many rows I can have? So that's going to get me thinking a bit. I'm not sure. So at least for 26, for the first one, I could say if column number is greater than 26, if column number is greater than 26, it's kind of like a counter that goes up to 26. I have to add another multiple. So for example, if it's 26, I divide it by that, it's 1, right? And then if it is 26, so let's take a look at this. So column 1 is A. Can I have 0 columns? So column number has to be 1. So at the minimum, okay, so let's solve it for at least 1 column, okay? If column number is less than 26, column number is less than or equal to 26, I know for sure I can return stores at that column number, and it will give me the corresponding array. So for example, if it's A for 1, I put in column number into stores, what's it called? Yeah, so I go column number stores. What did I do here? A is 1, B is 2, up till 26. What did I do here? Let's see, how did I fill up this element? So let me flip this. Let me take position, I'm gonna put I in here, and then increment position. That way I go 1 to 26 and it's the corresponding. That way if I have the column number from 1 to 26 and I just go stores column number, which is here, I get A. 1 is A, 2 is thing. So I return that, and at least, at the very least, I get the 1 to 26. So I solved it for 1 column. Now I have to figure out how to do it for multiple columns. So once it gets to AB, or like triple columns, right? If it gets to something crazy, So the only other thing now is divide by, or minus 26. This is going to be tough. This is not going to be tough. Okay, there's got to be a way around this. Let's see what time I'm at. If I hit, okay, I'm at 25 minutes. If I had 30 minutes, we're just going to try and look at solutions. Because like the whole point of this is to learn how to solve fast. So it's not here to sit and waste 2 hours on this question. It's here to get the joules from the question, answer it quickly, and then go to the next one. So that way when we reface it in the future, we can do it fast. Column number 28. How do I determine whether I need more than one row? So it's greater than 26. So I'm already handled here for less than 26. If it's greater than 26, it's going to be handled in the rest of the code here. So what I got to do now is go column number, 529.2K. I could do minus. But it's already assumed once past 26 that it's greater than. That's the thing. That's the thing. So I want to go. Is there an easier way to do this? ZY. So this is the disparity, because over here, I know I could just minus 26 from this value and then just add the remainder to B. So what I can do it has to be character I. So what I can do here, return stores thing. Otherwise, I go to stores Oh, okay, I could divide it. So divide it. Let's see, if I divide it, if column number divided, so I can go and figure out the leftmost element, so if it's A or not. And then I could subtract for the rest. So if I divide by 26, So for example, 28 divided by 26 should be like 1 point something, right? That's A, and then minus 1. 701, let's test that theory. So 28 divided by 26, or 25, goes 1.12. Right, if I go 701 divided by 25, I get 28.24. Divided by 0.24. So if it's 28 and then I could go till remainder is 0. So what I could do is 28 divided by thing is 1, right? So I get 28. So that tells me if I get 28, if I get to 25, I'm at Z. Right, so if I divide and I get 28, right, I'm just trying to figure out what I can do. So I could divide it. Once I divide it, I take whatever the number is at max. So for example, 28, right, minus 25. That means that I can go from A to 25. So if it's at 25, I get Z automatically. Then I could subtract 25 from this, which is 3. Okay, I'm just going to do some crazy math right now. 3.04. So then I want to times that. I'm just curious if this theory works. I want to times that by 25. Equals 76. I don't know why I'm timesing it by 25. I was trying to figure out, like, if I divide it, I get the number of rows. So the position A to Z for 1, and then what can I take away from it to start doing the rest? But it doesn't look like that's working. So what time are we at now? We're at 34 minutes. Okay, so it looks like I'm kind of stuck here, so we're gonna have to figure out what we could have done. Let's take the constraints. This is a bit more challenging, but let's see. It's probably going to be something so trivial, which is usually the case. Sometimes it's not good to overthink things too. Yeah! Oh my gosh, I just panicked for like a whole second. I nearly submitted it with nothing of my solution here. Your solution is right on track. So you can complete the implementation and cover all cases. Okay, so I have a column title. What the frig? So I have a column title, range thing. So I'm doing the right thing here. Handle up to 26, greater than 26. So yeah, see, this is what I was talking about. You have to have some sort of remainder, but I didn't know how to do it correctly because I was thinking of like dividing it. If you go back to if you scroll back like a few minutes, like if you divide by 26, you get like some sort of remainder. So if you get 1, like that tells you everything for one column, and then past 26 you have to divide again to see how many columns you get or something. So let's see when column number is greater than 0, handling columns greater than 26. So this pretty much covers it. So everything we assumed up to this point was correct. Now we just have to create this remainder function. This is the tough part that I was like doing mental gymnastics for. So it says while the column number is greater than 0, remainder is column number minus 1, get remainder for current digit. Column title stores remainder plus 1. If column number is less than or equal to 26. Yep, column number is less than or equal to 26 because Z is 26. Then we have to go column number, get remainder for current digit. So column number minus 1. This is column title. Column title equals stores plus column title. So yeah, you just add whatever is in itself to column title. Okay, so if column number is greater than 0, why is there a while loop? Handle column number is greater. Okay, column number minus 1. So this is the part that's a bit tricky. I'm not sure if this should be a medium level question, to be honest. Okay, let's see. Mapping creates a stores for thing 26 or less. Okay, that's me. Handling numbers for larger totals. Use a loop to continuously determine the remainder when column number minus 1 is divided by 26. Adjust column number to column number floor 26 for the next iteration. Oh, while column number is greater than 0. So what they're doing is they're whittling down the column number until it hits 0, till there's nothing left to divide. So for example, let's say we get column number you have to use the remainder to determine what your you have to use the remainder to determine what your value is. Your value of the column is. So for example, if, like when I go back to here, 28, divided by 26, you get 1.07 thing, right? So you get a remainder of like 1 or something. So for example, 28 divided by 26, the remainder is thing, so nothing. So while column number is thing, so column number -1 yeah, so it keeps looping until, and then adding values to my string. So remainder is going to be column number -1. Why do we do that? So continuously determine column -1 is divided by 26. So I just want to know why it's the reason for subtracting 1 from column before the pre-division and module operations is to handle the one-based indexing of Excel columns and align it with a zero-based indexing system, which is more convenient for computation. Okay, because column 1 is A, but for an actual index, we use 0. We zero index. Okay. I'll take that. Before performance, aligned with zero-based indexing system, which is more convenient for computation. One-based indexing cells are one-based. The first column is labeled A, which corresponds to 1, second is B, and so on. After Z is 26. The columns continue as 27, 28. Zero-based in most scenarios, including when dealing with modular and division operations. A zero-based indexing system where counting starts at 0 is more intuitive. Okay. Let's start by walking through an example, column number 28, to understand how the subtraction works. If you don't subtract 1 directly, I directly compute column number -26, 28, divided by thing, which corresponds to B, which would give A to the next iteration. Why? Okay. Because this gives you the remainder of what's left. With subtraction, subtracting 1 aligns the indexing. Column number -1 equals 27. So, correctly forms. Okay, so we're just matching the indexing by minusing that 1. Breaking down the math, so column number divided by 20, remainder, so modulo 26. Modulo finds the position of the current character by subtracting 1. We align from A to Z with a zero-based indexing from 0 to 25. So 21, 26, 1 becomes 1, which maps to B in a zero-based system. Okay. Let's see. After handling so division operation, column number floor 26. After handling the character division, shows by 26 the number down. Alternatively, removing the process character's contribution and allowing the next character sequence to be determined. Why this works? By subtracting 1, the algorithm correctly maps Excel numbering system, which starts at 1, to a computation-friendly system that starts at 0. This This alignment ensures that each iteration correctly defines the corresponding character and correctly constructs the Excel column title. Subtracting 1 also ensures that the base 26 system, where A is treated as 1, corresponds to 0 and 0-based indexing, is correctly handled when, okay. Okay, so let's go back to the solution here. This is the portion that I need. So basically what it's saying here is take what I already have. So my return value should be the column title. So now I just have to find a way to deal with the registers. So while column number is greater than 0, I need to figure out first the remainder equals, so after 26, so I have to go column number minus 1 modulo 26, because A to Z is actually 0 to 25. We're doing 26. So we have to subtract 1 from column number. Column title equals, so I'll just go plus equals. And then I want to go stores remainder plus 1. Prepend the corresponding character. This only occurs if it's greater than 26 because it would already return here. Stores remainder minus 1. So what I'm going to do is, so stores remainder plus 1 column title. And then I have to get the corresponding. So after you get one of the column numbers, you have to go column number minus 1 divided by. So the remainder is modulo, then you have to divide to get the next register, and the next register after 26. So basically checking. So for this is all to get the current column you're on. The next one is to get the next column. So to prepare a column number for the next set of calculations. So what's going on here is we're going to go stores, because column title we have to add the letters, so we have to go stores, we have to take the remainder value and add it. So let's say 26, 27. So for example, let's take 28, right? 28 minus 1 is 27. The remainder of that is 1, and we have to take the remainder minus 1. So it's going to be 0, which is A. So percent 26, 0. Because this is why they do the minus 1, right? The index in the dictionary is A1 to A, right? But the dictionary index itself to get this pairing of 1 of A is 0. So dictionary position 0 gives you A1. right? So don't get confused. It's like, oh, but A is 1 and it goes up to 26. No, that's how it works with the pairings of your column and letter. That's not how it works with the position in your dictionary. In your dictionary, position 0 is A1. You see what I'm trying to say? And that's why they do it here. So they go stores remainder 1 minus 1. Column number is going to be, so your dictionary is 0 indexed actually. So it's going from 0 to 25, but the pairs go from 1 to 26 for Excel. That's your output. So this is why it goes 26 modulo column number minus 1 modulo 26. So this gives you a remainder of 1. So for example, 28 minus 1 is 27 divided by 26, and you get a remainder of 1. So you go stores remainder 1. So you get, that's the value of 1 minus 1 to get A. So for example, I expect to get AB, right? So stores is going to add to column title this A value to whatever is already appended there. So right now the string is empty. I'm adding A from this remainder to my column title. You see what's happening? So right now, let's go to the whiteboard. We can zoom out. I wish there was a way to drag with this mouse, but beggars can't be choosers, you know? So I'm gonna erase this now. We already know what the values are. So right now this is column title, it's empty, right? I get my remainder, and that's equal to 1, right? So now when I go here, stores remainder minus 1, right? Stores remainder minus 1 takes me to the first dictionary entry of A equals A and 1, or 1 and A. So what I'm doing now is I'm adding, when I go to this line, which is column title plus equals stores minus remainder 1, I'm going this empty string plus the character A from stores, because this is the position of the first element. So stores at 0, stores at 0 is 1 and A. See what I'm saying? Stores at column number. We're going stores at remainder. So column number is 20 my thing, 1. So then we go to A. We add A here, and we get our output is A right now. And now we have our remainder, so floor. So now we go 26 divided by the column number. Where is it? So we go to the ChatGPT solution. It goes 28 minus 1 is 27, and then update column number. All right, so now we go 28. So if I go, let's first fill out this. So now we go to column number. We get the new column number equals column number minus 1. So we did the remainder up top. We have to do the actual division up top, floored by 26, to get the next registered item. So what happens here is, if we go to the whiteboard, we don't need this anymore. We did all this to get the first element. Now we have to get the second element. So it's 27 or 28 minus 1 is 27 modulo 26. So we got 1 as the remainder. Now we have floor division of this. So it's going to be 27 divided by 26. And now you get 27 divided by 26 floor. So you basically cut off all this and you get 1. So your next column number is going to be 1. So what is 1 in the dictionary? Position of the dictionary, it's this 2b. So you get AB. Because when you go into here again, you get 1 minus 1 is 0 divided by thing, so there's no remainder. Column number minus 1. So there's no, let's see, so 26 minus 1. So the new column number is now 27 divided by 26. So that's 1. 1 minus thing is 0 divided, modulo 26, nothing. So stores remainder minus 1 gives you the B value. It should give you B. Let's see, so column number thing 26. And then let's confirm it. I just want to check on chat GPT. And this should work now. So let's see. This plays with the registers. Column title. Column title, column title. Why is that wrong? So column number. Column title. Remainder. Did I spell it correctly? R-E-M. Remainder. Remainder minus 1. What's going on with this? So column title, remainder equals 1, rest, solution equal to parameter, column title plus equals stores. What if I do this? Okay, so it's gotta be plus equals. Remainder minus 1. What if I just take out the minus 1s from everything and just use the raw column number? Oh, what the hell? I'm just curious. Maybe it's because of the 0 index issue. This kind of makes more sense as well. Key error 0. Key error 0. What did I do wrong? So let's go to ChatGPT. Let's see what we missed here. Maybe they modified something from my previous solution. So I have this. This is all the same. Position 1. Position 1. Okay, I had that. And then I have my filling up the array. So position 1 and then thing. Let's see that. Filling up the array. Columns from 1 to 26. Stores, remainder minus 1. What did I do that correctly? Stores, okay. Stores, remainder. Plus 1. Oh, is it plus 1? Did I do minus 1 here? That's probably why. Minus 1, and then minus 1. Let's run that. Yeah, so minus 1, okay, cool. Minus 1, plus 1. Okay, so that makes sense because we're going to remainder plus 1 to get to the title. So the minus 1 is thing. So remainder would be, yeah. Remainder would be 1. 27. Modulo remainder is 0 plus 1, that's A. Gives you A, okay. Then column number is 28 minus 1 is 27. Divided by 26 floored is 1. So that should give you B. So what is going on? Should give me 1, which is B. Why is that not working? Maybe it's some sort of syntax issue. So let's see here. Is it a syntax issue? Let me paste this. Expected AB, I'm getting BA. Expected AB, I'm getting BA. Is it because of the 0 index? Let's try this. I'm just curious. Run. Okay, so it's minus 1. And then CB, so I was getting BA. So this will shift it back. So it looks like everything's shifted by 1. BA, and then I gotta flip something here. So it's gotta be column title equals this. Oh, because it's column title plus equals. That's not what it should be. Because the way it works is you append it to your string. Column title plus the next letter would have been B, right? So for example, the output's BA. We actually want it to be AB, so we have to go plus column title. We have to add it after the item here, if you know what I mean. So it's got to be backwards, I guess. Let's try that. Yeah, you see? It's because of the order of the string addition. You're going first. You're adding the item to this, so it goes from left to right. So if I added B in the next iteration, so right now when you have an empty string, column title is filling up A. Right. So let's hold this here. And then when I have column title coming again from the next iteration, it's adding B to A, so you get BA. Right now we want to add the new element to the existing column title. So we get AB. So we add the column title after. You see what I'm saying? You add it after whatever is happening. So that should be it. Because you want to add whatever the new item is to the existing column title. You don't want to add column title, which is A, to the new value, right? You want to add the new value to the column title, which already contains A. Let's see, prepend. So that's why it says prepend the corresponding character. Get the remainder digit. So let's see. Continuously divide by 1, adjust, and then let's quickly detailed explanation of this. Okay, so let's break down the process of converting a column number greater than 26 to its corresponding cell column title step by step. So focusing on why we subtract 1 from column number and how the loop works. Okay, so we go through column numbers A, B thing. So A, B for the first 26, we already know this. All right, this is already covered. We don't give a shit. Okay, now we want to go to the hard stuff. What goes on after that? So AA, AB, all the way to ZZ, and so on. This is a labeling system, essentially a base 26 system, where A corresponds to 1 and up to thing. Okay, so I did this already in my dictionary. challenged with larger numbers. So when converting a number like 28 or 701 to this letter-based system, we need to consider multiple digits in this base 26 system, similar to how we would in any other base, like binary or hexadecimal. Okay. Initialize a setup loop. The goal is to repeatedly extract the last character of the column title, which corresponds to the least significant digit of a base 26 system. Append the result, then reduce the column number. So they're pretty much adding it in reverse to whatever is happening. So it's like B, then A, because you want to get the lowest number and then subtract columns as you keep going until you hit the final one. We subtract 1 from column number to shift from a 1-based system, Excel columns, to a 0-based system, which is more natural for modulo and division operations. Okay, because we're going to be using floor, that's why. Modulo and division, we want to get remainders and floors, so we have to go 0-based. Second, consider a column number 28. Okay, so 28 without subtraction, 28% 26 modulo 2. So this is your remainder is 2, which maps to B in the first iteration. So we get B. Boom, put that here. With subtraction, 28 minus 1, so 27. 27 divided by 26. 28 minus 1 is 27. Okay, so that is base. So this percentage is 2, which maps to B with subtraction. So without subtraction, 28% 26 is 2. Maps to be in the first iteration, okay? With subtraction, 28 minus 1% 26 is this thing, which maps to be correctly treating 28 as the first position after A, which is correct for thing. So step 3, calculate the remainder and determine the character. Okay, so what's subtraction? This one is 27%, which maps to B. As the first position after A. Yep, that makes sense. Calculate the remainder and determine the character. So the remainder column number minus 1 gives us the position in the alphabet from 0 to 25. To 25 for Z. Column number minus 1. We use this remainder to find the corresponding character. If the remainder is 1, the character is B. Step 4, update the column number. After determining the character, we reduce column number for the next iteration by performing integer division by 26. So this step moves to the left in the column title, again, to shifting digits in the numeral systems. So now we're trying to find the next register, or the next item. We prepend the determined column title because we're processing the least significant digit or letter first. Okay, so when we loop again, if column number is greater than 0, we loop again if the column number is greater than 0, repeating the process until the entire column title is constructed. Number 6, return the final column number. Column title. So once column number becomes 0, loop terminates, and fully constructed column title is returned. Okay, cool. So column number equals 0. We're going to be flooring, so it's going to end up becoming 0 at some point. So let's convert column number 701, which corresponds to ZY. It shall state column number 701 title. This thing. Okay. So first iteration, subtract 1%, 26, we get 24. This is the remainder. Corresponds to Y. So if we're going from 0 base to from A to Z, 0 is A, 25 is Z, so 24 is Y. Update the column number. 700 floor 26 is 26. Prepend y to the column title, y. And then second iteration. Let's see. I don't know why they do this. I could just put it here. If we're going by the steps. Right now we just get column numbers and column titles. Yep, so we can close this whiteboard for now. Yep, so let's see. Where's it? Okay, so y26, prepend y to the column title. So now we go y plus the column title. So y is the current element, and then let's see, stores remainder plus 1 to the column title. So prepend y to the column title. Second row, column number is this 26 value. So subtract 1, you get 25. 26 divided by 25, you get 25 remainder. Because it doesn't even go to it one time. So you get 25 remainder. You can't divide it by that. So your remainder is the whole value, Z. Update the column number, 26 floor 25. It's going to be 0. So prepend Z to the column title. So now we have column title is Y from the last iteration. We take Z, we add it. Right, so now we have ZY. Loop terminates, and now it is 0. The final result is ZY summary. So if we go here back to this example, 701, we get ZY. Right, so we get the least significant digit for 26 base, add it to the end, and then we find the next one. Then we prepend that next one, add it, slap on the original. So it's like getting 701, right? We get 1, then we get the 0, add the 0 to the 1, so we get 0, 1. Then we get the 7, we get 7, we have the 0, 1, so 701. That's basically what's happening here. So let's try submitting it. 51%. So this is it for that solution for Excel sheet column title. So if you like that video, please give it a thumbs up. Put your comments in the comment section below. I would personally give this a medium or a hard, because I wouldn't expect someone to just understand the registers off the top of their head. Right? What makes it easy is the first 26 titles, right? But like thinking about how to organize the register is a bit more tricky, as you've seen. So yeah, give it a thumbs up, put your comments in the comments below, subscribe to the channel. Knologist out.